Hello, welcome to this video. In this video, we'll be looking at parameters and functions. So first, we want to prove this phenomenon that we've been given, that dy dx is the reciprocal of dx dy. Now, we already know that a small change in y divided by a small change in x is the reciprocal of small change in x divided by a small change in y. Now, as delta x tends to 0, delta y will also tend to 0. Then delta y out of delta x will tend to dy dx. And similarly, delta x out of delta y will tend to dx dy. Therefore, what was originally this becomes this, that dy dx is the reciprocal of dx dy, and vice versa. Now, this is going to be useful to us when we're looking at the parameter functions that we have, but it's also useful in rates of change. Okay, so let's start with this question here. If x is t cubed plus t squared, y is t squared plus t, we've been asked to find dy dx in terms of t. Now we know from the chain rule that dy dx is dy dt times dt dx, but we have x in terms of t and not t in terms of x. And you see that from these equations, it might not be easy for you to write t as a function of x. So what do? We'll have this as dy dt multiplied by the reciprocal, divided rather by the reciprocal dt dx, which is dx dt, like we've seen from our previous slide. So since y is t squared plus t, that means dy dt will be 2t plus 1. And since x is t cubed plus t squared, that means dx dt will be 3t squared plus 2t. And so this would simply be 2t plus 1 out of 3t squared plus 2t. And you'll have completed the question. We'll have found dy dx in terms of t. Now, you might want to check and confirm if this is indeed true. Our equations are y is equal to t squared plus t, and x is equal to t cubed plus t squared. Notice that this is t times t squared plus t, which is ty. Therefore, we could write t as x out of y. If you go ahead and substitute that in the equation for y, you have your y as x squared out of y squared plus x out of y. And so your equation here is y cubed is equal to x squared plus xy. You can see that this is an implicit function. Now we want to get dy dx, differentiate both sides with respect to x. On the left hand side we'll have 3y squared dy dx. On the right hand side we'll have 2x, xy is a product. This is going to be x dy dx plus y. So this is the derivative of the right hand side. How do we get dy dx? We make dy dx the subject. You have that dy dx times 3y squared minus x is equal to 2x plus y, and therefore dy dx is equal to 2x plus y out of 3y squared minus x. Now, when you actually go ahead and substitute, substitute these two equations into this, you'll actually get the exact same thing as what we got here. But I'll leave that to you for you to check it out. Okay, now let's look at another question rather. So a curve is defined by parametric equations. X is equal to 2t squared, y is equal to 4t minus 2 to the power 4. We've been asked to find the equation of the tangent to the curve at the point 2, 3. Okay, so what do? We need to find dy dx. X is 2t squared. That means dx dt is 4t. About y, y is 4t minus 2 to the power 4. That means that dy dt is 4 minus 4t cubed. We know that dy dx is dy dt from the chain rule multiplied by dt dx. But we know that dt dx is just 1 out of dx dx dt. So we could similarly write something like this. Now dy dt is 4 minus 4t cubed, and dx dt is 4t. So this could reduce to 1 minus t cubed out of 1 minus t cubed out of t. Now, this is dy dx, the equation of the gradient of the tangent to the curve at any point. But we've been given coordinates in terms of x and y, so we need to find the value of t when x is 2. Now when x is 2, we could substitute that in this equation. We'll have 2 is equal to 2t squared. That means t squared is equal to plus or minus 1. We can't exactly, t squared is equal to 1, and that gives us t being plus or minus 1. We can't exactly tell whether it's positive or negative. So we'll use the equation of y to help us figure that out. Y is, when we substitute, t being positive 1 into that equation, we'll get 4 times 1 minus 1 to the power 4, which is 3. So that means t is positive 1. You can see if you substitute a negative 1, then you wouldn't get 3. So that would be a different point. So at the point 2, 3, t is equal to 1, positive 1. And so dy dx at the point 2, 3 is equal to 1 minus 1 cubed out of 1, which is 0. So the gradient of the tangent to the curve at the point 2, 3 is 0. So what do we do? To find the equation of the tangent at that point, you could use y minus y naught is equal to divide by x out of x naught is equal to the gradient, which is 0. And so you have that y minus 3 is equal to 0, since the x minus x naught will just be multiplied with 0 and give us 0. And so y is equal to 3 is the equation of the tangent to the curve at the point 2, 3. And so that's how we use chain rule, and that's how we get the point, the value of t at such a point. We'd have to use the equations that were given, and then simply substitute for t in our expression of dy dx with the appropriate t value.